Hey guys, good evening and welcome back to my another video. Um, yeah, it was a nice day for me. I went to The Hague to get a haircut because Dutch barbers rarely know how to cut an Asian hair because our hair is a bit stiffer than the European hair, so it's hard to handle. But anyways, I got great results and came back and worked on this linked list problem that I'm showing right now on my screen. I first of all used a method that just popped to my head. Um, Also, before we start, I observed that for linked list problems, usually they specifically tell you to use the linked list. So I don't think there's any confusion with that. But the method that I use when I read it afterwards in the solution, they told me that it's something that we should avoid from using because interviewers often want um, a specific approach to this kind of problem, which I'm going to discuss today as well. It's called fast pointers and slow pointers. And yeah, at a first sight, when I first saw it, it looked really eloquent, delicate, and yeah, whoever first came up with the idea should be praised, I think. But without further ado, let's first start with explaining my idea. Um, so the method that I used is okay. So for the problem, you have to find a middle node of the node given. So let's say that there's one, two, three, four, five. You want to find a middle node, then that would be 3 and 4, 5, right? Because they're all linked together. The same goes for this linked list. However, in this case, there are even number of nodes, which means that as the question specifies, we have to return the second middle node in an even number of cases. So basically, 6 divided by 3 is 3. Um, so that's 4. So given that when we divide the length of the linked list into two, we would always get the position of the head of the middle node, right? Because even in okay, in the case of an odd number, if oops, um, yeah, in a case of an odd number, the middle node would be n divided by 2. So in this case, n is 5. So 5 divided by 2 will still be 2, um, rounded down. So that would be 0, 1, 2. So index 2, which shows already the middle node. In the case of the even number, like you guys must have already seen it, but n divided by 2, in this case, 6 divided by 2, 2 is 3, also 0, 1, 2, 3. So yeah, it already specified the second middle node. So it already does what the question asks. So my idea was um, instead of continuing with the linked list, we first convert it into a list, into an array, and then we try to sort it from the beginning. And then when we return it, we divide it by 2 to return the second middle node. Um, so yeah, let's try coding it, my first solution. So basically, mm, right. So we just convert the head node, right? So that would be array equals list on head. Now, while we're in this loop, while array minus one dot next, we have to append it from the start, right? Because we're reorganizing it from start, head, and then the next node and the next node, so on and so forth, from the back. So that will be array and minus one. Next, maybe I should code it first and then try to explain. And then, if not, we return length. Right? And yeah. Unmatched. Oh, wait. Yeah, so you can see 3, 4, 5, 3, 4, 5. So we initialize an array with the head node, and then what we do afterwards is we check if the last node in the array list has the next node, and then if it does, the loop continues. And here, what it does is we append the next node of the last node in the array list to the list array. And this just keeps on adding each subsequent node in the linked list to the array list. And then at the end, like I said, we return the middle node by dividing by 2. And yeah, that's about it. But this solution wasn't really complete because it didn't use the fast pointer slow pointer method. So I'm gonna first try to explain what a fast pointer slow pointer in this kind of situation would be. So basically, fast pointer is like when you have, so so let's say that you have 5 nodes, and then you have a fast pointer and a slow pointer. What it does is fast pointer goes twice as fast as the slow pointer. So when the slow pointer goes 1 node, it just jumps 2 nodes. So it will have n divided by 2, the speed, I mean, and the slow pointer would have just the n speed. So when the fast pointer completes this one iteration, the slow pointer's position, when it's given that it started at the same time, would end at the middle node, right? So by using that slow pointer, we're essentially calculating where the middle node is in that array, right? So when I first saw this solution, it was just like a mind blowing. So it would be like fast pointer is a fast next dot next, right? Because we're doing two jumps at the same time, and then slow would be slow dot next. Let's try to code this and then see how it works. Yeah. So we first initialize the slow pointer, fast pointer, like we did in the sliding windows. So that would be head equals slow equals fast, right? And while fast and fast done next, slow equals, so while fast is reaching the um, so when the loop is initiated, slow dot next, fast equals fast dot next, right? And then when the loop finishes, we return slow. Mm. Oh, maybe we have to fast equals. Yeah, so we just had to assign a fast variable first. But anyways, this is how you do it. Yeah, much simpler, although the other one was easy as well. But this one is just like adding on to the um, real logic of how algorithm works, right? So yeah, I like this solution. It's really easy to visualize as well. And I hope to use this on other examples as well. Probably I'm going to do a few more examples tomorrow and build on our knowledge. All right, that's it for today. Thanks for watching, guys, and hope I see you tomorrow.